So from polar to Cartesian is okay. Good morning, everyone. Questions from the homework, please get started. Any questions? All right. Okay, so I will start, and I think I pick up from where I started yesterday. No, sorry, I pick up from where I left yesterday. So we have the following. So yesterday we learned how to convert from Cartesian to polar and vice versa. So we learned how to convert from polar to Cartesian. Sorry, I need to mute some students. I don't know where the noise is coming from, so I have to mute. Okay. All right. So we learned how to move from polar coordinate to Cartesian. And that was easy. X is r cosine and y is r sine. So we did that. And then we learned how to go from Cartesian to coordinate, to polar. And the guideline is the r square is x squared plus y squared. And the theta, I told you that that's the formula you can use for theta, but you have to be careful with how to find theta. So this will give me theta is the arctangent y over x if I am in quadrant 1 or 4, but you have to add a pi if you are in quadrant 3 or quadrant 2. So that was what we mentioned yesterday. And then the last thing, which is we're going to take from today, is the following. We start talking about polar equation. It means equations that give you a relationship between polar coordinate of the point, not the Cartesian coordinate. So, for example, suppose I have a circle centered at the origin. So, circle centered at the origin and radius 4. I just picked 4. So this circle have 2 different equations. So this is my circle. Okay, that's my circle. I centered the origin. I have 2 different equations. In Cartesian coordinate, it means if I take a point, I look at the x and y, and I try to find the relationship between x and y. In Cartesian coordinate, the equation is x squared plus y squared is the radius square, which is 16. So if I try to find the relationship between the x and y, that's in Cartesian. Now, in polar coordinate, it means if I take a point on the plane, and on the circle, and I start asking myself, what characterize the r and the theta? The r and the theta. So in polar coordinate, this equation becomes fairly simply r equal to 4. So this is a circle. You can take its equation in two different coordinate systems. In the polar, it's fairly simple, r equal to 4, because what characterizes every point here is that its distance to 0 is 4. So that's equation in polar. In Cartesian, it becomes x squared plus xy squared equals 60. And when we are working, and eventually that's what will happen when you guys hit calculus 3, you will have to decide which is the easiest coordinate to work with. Is it Cartesian or polar? A lot of time working with circle, it will be easier to work with polar because the equation is fairly simple. So two more examples just to also emphasize the importance of polar, why they are really used. So another example. This example is, suppose I take a line all the way through the origin. Okay, I'm taking a line through the origin. So I'm going to draw my line, this line. And let us say this line forms a certain angle. So a reasonable angle here is, let us say, pi over 3. Okay? So this line can have two different equations. It can have an equation by using the Cartesian coordinate, and it has another equation using polar. All right? So polar, it means if you take any point on this line, what characterizes its polar coordinate? That's what finding the equation in polar coordinate. So who can tell me what's the equation of this line in polar coordinate? Means how you characterize the polar coordinate of point on this line. I want the answer on chat. What characterize point on this line? What characterize the polar coordinate of point on this line? Absolutely, theta is pi over 3. Any point here, r could be anything. Like here, r could be is negative, theta is pi over 3. R is negative, but theta is pi over 3. R positive, theta over 3, R positive. So what characterizes them is that in polar coordinate, it's very easy to write the equation of this line. As long as go through the origin, because it's important. Otherwise, it's very hard. In Cartesian, this is not also hard because that's a typical line, y equal mx, because it goes through the origin. And what is m in this case? Can we find m in this case? What's the slope? Can anybody figure out the slope? I have a point. To find the slope, I need another point. I'll give you a hint. I'm going to take the following point. I'm going to call this 1, and I will take this point here. Okay, so if this is 1, what's going to be the slope? I think you should know that. Can anybody figure out the slope? I gave you a hint. I gave you this one. Any hint, any idea? So this is 1, and I don't know, something. Okay, let me give you. Is this the slope? Is this the slope? Because this is a point and this is a point. So what's the slope? If you go 1 unit, the rise is the slope. Can I find the slope using a bit of trigonometry? If I take the tangent of pi over 3, what do I get? You can use that, or tangent is easier because I took a 1 in here. What's the tangent of pi over 3? It's the slope, m, divided by 1. It means that the slope here is nothing more than the tangent of pi over 3. It's a fact that I guess it's good for you to know. So in Cartesian, this would be the tangent of pi over 3. It's the sine, which is square root of, so this is the square root of 3 times x. So that's a line. In polar, theta equal pi over 3. That's what the equation of this line in polar. In Cartesian, it becomes a little bit harder, square root of 3 times x. So it's very easy to describe this line as long as it goes through the origin in polar coordinate. Now, the last example, which will actually elaborate a little bit more why polar coordinates are very good to describe region. So let me take the following region that I took yesterday, this region. And you have a circle. Suppose I take 1. And then I have another circle. So this is, let us say, 4. And I'm interested in this region, let us say. How can I describe this region? Using polar coordinate. So I want you to describe this region using polar coordinate. Means that if you take any point inside this region, what characterizes its polar coordinate? So this point here. What characterizes the r? What characterizes the theta? And is it a very easy characterization? Okay. What characterizes the r? R is the distance from here to the point. What characterizes the r? Between 1 and 4 inclusive, as long as I include the boundary. So very easily, r between 1 and 4. I'm including those. I don't have to. What about the theta? Is it easy to characterize? What about the theta? All of you. If I point here, the angle that this will have to form with the polar axis, what can you say about it? The theta is between 0 in this particular situation and pi over 2. So, exactly. So this region is very easily described using the polar coordinate. Little bit harder using Cartesian. Little bit harder using Cartesian. If I want to describe it using Cartesian, I'm going to say that x squared plus y squared, it means the distance from here to here has to be between 1 and 16. That's the distance. But that's not enough. This will only characterize all the point in this ring. And then I have also to say x positive and y positive to be characterizing this. So in Cartesian, I need this explanation. In polar, I need this kind of specification. Now, when I have to describe a region that looks like this, it's very similar to that, but I'm going to do a little bit of a change, and then polar will be definitely the way to go. So suppose I do the following region. So that's the importance of polar. That's why they are used tremendously. So suppose now I want to describe this region, this way and this. And I'm going to take, instead, this is theta equal pi over 3 and theta equal pi over 4. And that's the region I am interested in. Describing this region using the x and y, the Cartesian, is actually fairly difficult. Describing this region using polar is very easy. So that's really when polar are used. Anything circular we use. So here I can describe it. Suppose I put 1 and 4, the r between 1 and 4, the theta between pi over 3, and let us say whatever I put over there, suppose 3 pi over 4. Okay, so that's really very important feature of polar. It describes region extremely well. Okay, so today we're going to keep sketching curves using given in polar coordinates. So I will start with a simple example. This is the section where I don't like to do it online. I wish I was with you, but I have no choice. So question now is, sketch the curve whose polar coordinate is given by the following equation. Okay, so sketch the curve given by the following polar equation. What does this mean? Means I want to sketch all the points whose polar coordinates are theta satisfy this equation. Okay, so whatever theta is, r is 1 plus sine theta. So if we go back to like something simple in Cartesian, if I wanted to sketch y equal whatever, y equal 4x plus 1, okay, in elementary or middle school, you were taught basically to take x, to take y, pick values here, and value for y, like -3 and 5, go to your plane, put those points, connect them. That's what we did. And we will imitate this process here. So what do I mean? So I want to sketch all the points that satisfy this equation. It means all the points that given theta, this should be R. So I'm going to do exactly what we do if we were back in middle school. I will take value, so R is changing with theta. So basically R is a function of theta. So I will take values of theta and I will take values of R and find the corresponding values for R. And I will sketch right here my findings. So I'll take theta to be 0 and my R will be 1 plus sine of 0. Now I'll graph the sign in front of us right here. That's the sign. Sine of 0 is 0, that's 1. The points here are polar coordinates. So if theta is 0, it means I am right here. My R is 1, it means I am 1 unit away from here. So this is the point 1, 0. That's the R, and that's the theta. Now, pi over 2. And I left a spot because I need to. What is my R? It's 1 plus the sine of pi over 2 equal 2. So this will correspond to the point 2 pi over 2. This one corresponded to the point 1, 0 in polar. All those are polar. So theta equal pi over 2, it means I start from the polar axis to here. Theta equal pi over 2, it means I am on this line. And my R is 2, it means I am 2 units away. So that's the point 2 pi over 2 in polar. Now what's happening in between? So what's the curve looks like? Okay, I will take in a value in between, pi over 4. The R would be 1 plus the sine of that, it means 1 plus the square root of 2 over 2. So when theta is pi over 4, remember theta, we measure it from here to here. Means when theta is pi over 4, R is a little bit more than 1. So it's right there. So this is pi over 4. And this is my R, which is 1 plus square root of 2 over 2. And I cannot plot every point. I mean, this is really, really tedious. So intuitively, how the graph looks like. It's going to start here and go like that. Now, so remember, I'm drawing the R and the theta. So this is pi over 4. Then if I take pi over 3, I will have 1 plus sine pi over 3, which is square root of 3 over 2, which is a little bit more than that. And then it will be 4 pi over 3. So I sketch the R. But I have to keep going. I have to keep going. And it's tedious as you realize. But for the first thing, I will do it the tedious way. Then I have to keep going. Okay. I have to go around the circle because I want to know what's happening after that. So I will go to pi. Now what's the value at pi? 1 plus. The sine of pi is 0. It is 1. So this will give me 1 for R, pi for theta. It means if theta is pi, I'm right here. R is positive. It means I am right here. So that's the point. 1 pi, be very careful in polar. So r is 1, it means from here is 1, and pi, I'm talking about the angle. And what happened between them? It means between when theta goes from pi over 2 to pi, what happened to r? Is it decreasing or increasing? What can you say? It's decreasing because sine theta itself decrease from pi over 2 to pi. It means the r, as theta sweeps this region, the point that satisfies this equation is actually the r is decreasing, causing the graph to go like that. All right, we're not done because we have to take all possible values of theta. So we have to keep going. So now 3 pi over 2. And then I connect that. What is the r? 1 plus the sine of pi over 2. Now what's the sine of pi over 2? 3 pi over 2. The sine is minus 1, which is equal to 0. So when theta is pi over 2, r is 0, and theta is 3 pi over 2. But this corresponds to which point? This corresponds to which point? 0 for r, as I said yesterday, that corresponds to that. So when theta is 3 pi over 2, r is 0, it means we're right here. But this is really very unsettling. What's happening in between? What's really going on in between? So for this particular, I need at least one value in between to know what's happening. So one value in between would be like a 5 pi over 4. Those are easy values. And I will have 1 plus the sine of 5 pi over 4. If you guys remember, it will be minus square root of 2 over 2. So what's the picture now? At pi, I am at 1. Then r is 1. So this point here is 1 minus square root of 2 over 2 and 5 pi over 4. So 5 pi over 4 is right here. So when theta is 5 pi over 4, r a little bit less than 1. R is going to be like this. And how this is going to look like, r is going to basically decrease, 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 and then it's going to be equal to 0. Very good. Now 2 pi. What is r at 2 pi? 1 plus the sine of 2 pi. The sine of 2 pi is 1. It's equal to 2. It means the r is 2 and theta is 2 pi. So r is 2, sine 2 pi is 0. So it is equal, I'm back to here. In between, you can take values and you get that. And now do I need to take more values of theta? Yes or no? If I start taking values after 2 pi, so I take 2 pi plus something, because the sine is periodic, then I will come back to the same value. So 2 pi will take the same r as 0. If I take 2 pi plus pi over 4, because the sine does not change values, when you add 2 pi, I will be back to 1 plus square root of 2 over 2. So the graph start here, go, and then start going around itself. That's really what the graph would look like. Okay, and that's the graph given by 1 plus sine theta. Okay, now, it's a good graph, but it's tedious. Do it this way. Do you agree with me? Is it tedious? Yes or no? Yes. So how can we go around this? How can we be a little bit smart and try to sketch this graph without having to draw all those points? It's going to be a little bit hard at the beginning, but you will get used to it. So roll your sleeve. Okay. So the second approach I will do is somehow I want to avoid plotting so many points. What I will do is the following. I'm going to ask myself, a theta vary from 0 to 2 pi. A theta change. Theta go through this region. What does R do? When is it increasing? When is it decreasing? So if I know the behavior of R as a function of theta, I can copy this behavior and see how my graph looks like. So at this stage, I'm going to do the problem all over again, but I will do it in a slightly different way. So again, this is R equal 1 plus the sine of theta. And the way I will do it is like this. Try to follow me the best. I'm going to sketch two graphs. The first is the regular graph that shows me how R will change with theta. In other words, I'm going to sketch the following graph. Now I am back in the Cartesian mode. So here I will put theta, and here the R-axis, that's the Cartesian plane. And I will sketch the graph of 1 plus sine theta. This is like sketching the graph of y equal 1 plus the sine of x. My goal is to see how is R changing with theta. What's really going on? So it's basically, I want to first sketch the Cartesian plane y equal 1 plus sine x. But how do we sketch 1 plus sine? We start with the sine. That's my sine. That's the sine. If I want 1 plus the sine, I take the graph of sine and shift it by 1 unit. So now what I'm doing right now is I am not sketching the polar coordinate r theta that satisfy this equation. I'm just asking myself, how is R changing with theta? So 1 plus sine theta is the graph of sine shifted. So this horizontal line, this will be shifted here. And the sine, so this has become a 1, and this will go up here. And you will see in a minute how I'm going to use this in. That's the 1 plus sine. So what does this tell me? If theta is 0, R is 1. That's what I'm reading this graph. And so this would be, according to the picture, will be the pi over 2. This will be the pi, 3 pi over 2, and 2 pi. If pi over 2, theta is pi over 2, R is going to be 2, which is, we know that. If theta is pi, R will be 1 plus sine of pi 0, it will be 1. Theta is 3 pi over 2. So I am, instead of making this table, I am actually putting all the info I want on this graph. So I don't have to sketch a table. And it's easy to sketch this graph because we know the sign of theta. But this also tells me the following. When theta takes value between 0 and pi over 2, R increases. Between pi over 2 and pi, it decreases. Then it decreases. It's 0 right here, and then it's increasing. I will use this picture that you see to sketch the actual graph. So how I will sketch the actual graph. So right here, I am in the polar plane. It means, sorry, right here, this is theta equals 0. Right here, this is theta equal pi over 2. And now I want to sketch all the points that satisfy this equation. That's the hard part of this whole thing. If we get that, we will be all right, kind of. But how I will sketch them, and I want to change one thing. I want to do it this way again, right there, because I want both at the same time. I want you to show both at the same time. Okay, so here I will sketch. Okay. So this is theta equals 0, and here is the theta equal pi over 2. And watch how I'm going to sketch this. I say, if theta is 0, R is 1. Yes, sir. R is 1. So theta is 0, R is 1. If theta is pi over 2, R is 2. That's theta pi over 2. Now, when theta goes from 0 to pi over 2, in the polar plane, it means as I sweep this region, because theta is the angle, and theta goes from 0 to pi over 2, this tells me that r is increasing. So I know the behavior. So if theta goes, the r is how far I am from the origin. And if theta increases, this tells me that you're gonna get farther and farther away from the origin. So I'm gonna put 1 here to be more realistic, because this is a 2 in here. So as theta sweeps this region, my r is actually increasing. So that will give me the first picture. So the way I like to do it, it means this piece of the graph is interpreted right here. So the theta sweeps this region, my r increases. Now, when my theta is in this quadrant, it means when my theta is between pi over 2 and pi, what's really going on? At pi, I am at 2. At pi over 2, at pi, I am at 1. So if theta is pi, I am right here. But in between, what is r doing? So it means if theta takes value between pi over 2 and pi, what's r doing? So right here, the horizontal distance represents r. And this tells me that your r is actually decreasing and decreasing. So my r right now will decrease. So this is the r. It's going to get less and less. It starts at 2, and it's going to move all the way down. So I'm using this to actually graph that in a very accurate way. So I don't have to plot million points to see the behavior. Now, so if this is the region 2 in here, that's what corresponds to 2. That's my interpretation of it. Now I want to see what happened between pi and 3 pi over 2. Okay. At pi, I am here. At 3 pi over 2, my r is 0. It means I'm the origin. But as theta sweeps the region, as theta starts increasing from pi to 3 pi over 2, what is r doing? This tells me, you know, your r here is decreasing. It means the distance to the origin is getting less and less till it hits 0. So my r here, this is my r, is taking smaller and smaller value till it hits 0. So I'm 100% sure now of the behavior of my curve. Finally, so if I call this piece here 3, this is 3. That's the interpretation of 3. Finally, between 3 pi over 2 and 2 pi, it means as my theta now start going from 3 pi over 2 to 2 pi, what is my r doing? My r is starting to increase, and at 2 pi, it'll go back to 1. Now I can take after that, but then if theta start increasing more than 2 pi, the graph repeat himself, which means for me that the r will start repeating themselves. It means I will be rotating around the same. So that's very good way of actually graphing that doesn't really rely on point, but rely on real analysis of how r change and theta change. Remember, theta is the angle and r is the distance to the origin. Okay? Which one do you prefer, 1 or 2? Plotting point or thinking this way? Any input? Okay. Now I'm going to take another example, which is harder. Which is definitely harder. And then I will take you back to the calculator and tell you what the calculator is doing, because we can graph those on the calculator. So I will take another example, and I'm warning you, it's a little bit hard. So, but before I take it up, let me remind you of the negative r. So if I have the point minus 2 pi over 3, polar, r theta, in which quadrant this would be? 1, 2, 3, or 4? Quickly. In which quadrant this point would be? 3. It's crucial to know that. It means this is the point 2 pi over 3. It's right there. That's the point. So it's the point opposite to that. Totally opposite with respect to the origin. So keep remembering this idea. Now part 2 is I'm going to sketch another graph and I will do it as slowly as I can and try to think with me, because this is the piece where I usually let the students work on it by themselves and try to get them to understand it, but I can't do that now. So part 2 is I will sketch the following. R equal, let me see, probably if I put this paper that, yeah, this would be, I can do, yeah, I think this will be easier. I will try this way. So R is 1 minus 2 sine theta. Means I will sketch all the points whose Cartesian coordinate satisfy this equation. I can plot point, but believe me, plotting point will not really give me a good graph. So I will do it by doing 2 graphs. The first that tells me how is R changing with theta. So it has nothing to do with what I want. It's just telling me how is R changing with theta, and I use this to be able to interpret the real picture. So to do that, I need to graph. So this is the first graph is nothing more than the regular Cartesian. It means right now, imagine that I am graphing y equal minus 2 sine x. That's really what I am doing. I'm asking myself, how is R change with theta? All right, so I need to graph 1 minus 2 sine theta. So how is the graph of 1 minus 2 sine theta? And here I would like to, because I want to sketch it, but I remind you, how do you sketch those graphs? If I am doing it, first I start with 2 sine theta. We know what 2 sine theta looks like. 2 times sine theta, it will take the graph of sine theta and stretch it by a factor of 2. Minus, it will take the graph of sine theta and flip it. So minus 2 sine theta would be this way. So that's minus 2 sine theta. Just to help us. It starts here. It goes minus 2 up. Here, then it starts repeating itself. So that's at 2 pi. And this is my pi. 3 pi over 2, and this is minus 2, and this is it 2. Now I'm interested in 1 minus 2 sine theta. How do I get that? I take this graph and shift it up by 1 unit. So basically everything will be shifted to right there. So this point will be shifted, this will be shifted, everything will be shifted up. And that's exactly the one I want to draw right here. So how will I draw it? I basically take this one because that's the midline that I'm going to be shifting. And then I shift it. The graph starts here. It goes down by 2 units. Then it's going to go up. And it's going to go up by 2 and then come back here. So this is just the graph of that. So let's see. So this here, those are important points. So this is important. And this is where the 2 pi is. The peak is happening at 3 pi over 2. This is where the sine, and this is pi over 2. Okay, so this is my how R changed with it. And now the slightly different, the hard part is, how can I take this info and start to sketch all the points that satisfy R equal 1 minus 2 sine theta. All right. So let me start. If theta is 0, right there, my R is 1. Whether you look at your graph or you plug it here, you get 1. So if theta is 0, R is 1. So let us say this is 1. Okay? Now, what is theta doing? When theta go from 0 to pi over 2, what is R doing? It is decreasing, right? So R is decreasing. but at some point, my R start taking negative value. So R will decrease up to here, and it's positive, but from here to here is taking negative value. So how am I gonna sketch those points? So at this point here, what's the value of R? Right there. What's R here? Please write on chat. What is R here? So if I sketch the graph, R here, it's 0. It means whatever the angle here is, my R is 0. So between those two, what's happening? R start at 1, and R start decrease, and then it's 0. But the question to me is, when is it 0? It means when it hits this point. I cannot graph otherwise. I have to find this value. So how can I find this value? I go back to my equation and I say, which theta give me R equal to 0? So I have to solve for it. I have to solve for the theta that give R 0. So it means 2 sine theta equal to 1. I'm solving for theta. I need to find this value. It means theta equals, sine theta is a half. It means theta is, we know it's between 0 pi over 2, is the arc sine of a half. It means the angle whose sine is a half, which is pi over 6. That's my theta. Which means that right here, this unknown value to me is not unknown to me anymore. This is the pi over 6. So piece by piece, I will analyze. So if theta between, so this is my piece 1. For theta between 0 and pi over 6, my R is decreasing. So the first thing I'm going to do right here, and you guys will have to do it, I will draw the line theta equal pi over 6. So this is the line, those are important lines, pi over 6. And now I will interpret from 0 to pi over 6. As theta sweeps this region, the R, which is vertical in this case, but in here, the R is the distance to the origin. The R is decreasing, decreasing all the way to here. So this is only this piece that I analyzed. Now the hard piece. Between pi over 6 and pi over 2, we call this piece 2. What is R? What is special about R? What's the problem with R? Between here and here, it means if I take R to be, if I take theta to be pi over 4, a number between pi over 6, pi over 2, and I plug it in the equation, my R is going to give me a negative number. So between, when theta is here, when theta starts sweeping this region, the R is negative. It means the R is not going to be here. It's going to be right here. The point is not going to be here. The point is going to be right here. So for example, if I take something between pi over 6, pi over 2, suppose I take pi over 4. Theta is pi over 4. And I plug pi over 4 in the equation for R, I will get 1 minus 2 times the sine of pi over 4, which is the square root of 2 over 2, which is 1 minus the square root of 2 over 2. Now, square root of 2 over 2 is almost 1.4. I will get that point. So if theta is pi over 4, I'm taking this as a special case. If theta is pi over 4, my R is minus 0.4. It means the point, the polar coordinate will be this one, minus 0.4 and pi over 4. So if theta is pi over 4, where my point would be? My point is not going to be here. My point will be right there, because R is negative. If I take R to be pi over, theta to be pi over 3, If theta is pi over 3, right here, the graph tells me R is negative. So the graph tells me if theta is pi over 3, your point is down here. So when theta is between pi over 6 and pi over 2, the R is negative. It means the points are not in here. My points are in the piece which is opposite to it. My points are right there. At pi over 2, right there at pi over 2, theta is -1. It means if theta is pi over 2, the R is -1. My point is here. So what's happening between pi over 6? If theta sweeps this region, the R is negative. It means the graph is in the opposite side. And R is getting more and more negative. It means the distance is getting farther and farther away. So the point is where the graph will be right there. That's the graph. So between pi over 6 and pi over 2, the graph is not here because my R is negative. The graph will have to be right there. That's part 2 of the interpretation. If you understand this, we're in a good shape. If you don't, you have to think through that because that's really the hardest part here. Now, what happened after that? R remains, so after I pass pi over 2, I have to move forward. I'm going to let theta now keep moving. What happened to R? I have another issue. R is staying negative. R is staying negative, less negative. R is staying negative until here. R is 0. But what is this value here? Okay, now, at this value here, 1 minus 2 sine theta is 0. So when I saw that, I gave you theta equal pi over 6 only. But that's not the only value for which the sine theta is a half. There are a lot of values where the sine theta equal a half. If we remember our unit circle definition, the sine is the y-coordinate. That's the sine. Pi over 6 is that angle. But there is another angle. We have the same sign. It's this one right there, which is pi minus pi over 6. So the other one would be pi minus pi over 6, which is 5 pi over 6. So the sine of theta is a half for two values, pi over 6 and this one. This is the 5 pi over 6. And that's another important value. So now before I go on, I have to see what's happening between pi over 2 and 5 pi over 6. So I immediately have to draw the line 5 pi over 6. Immediately, I have to draw this line. And what's the importance of drawing this line? At theta, go from pi over 2 to pi over 6. What do we know about R? R is negative. Means the point that satisfies this equation is not here. The point is down here. If I take R here, sorry, if I take theta here, the R will be negative. It means the point will be right there. And the R, according to this graph, is negative but getting less and less negative, which tells me the points are becoming closer and closer to 0. At 5 pi over 6, that's exactly where I hit this point right there. So now we build a piece. One piece of the curve, the second piece, a third piece. After that, it's usually easy when R is positive because I don't have to go to the opposite side. I stay with where theta is. Now, when theta is between 5 pi over 6 and pi, okay, at pi, if theta is pi, R is 1, so it's right there. And if theta change from here all the way to here, what is happening to R? It's at 0, but R start increase, increase, increase till 1. So now right there, R is increasing. And this is the point 1, 5. Now, between pi and 3 pi over 2, what's happening? What's happening is the following. Okay. At pi, I am at 1. At 3 pi over 2, 3 pi over 2 here, R is positive, and at 3 pi over 2, because everything was shifted, R is actually equal to 3. So at 3 pi over 2, I am here. But what is theta doing? What is R doing? As I go from pi to 3 pi over 2, my R is actually increasing. And it's positive, so it's behaving very well. So it means the distance is very nicely behaved, the graph like that. Finally, between 3 pi over 2 and 2 pi, sorry guys, what's happening? So at theta now go from here all the way around. At 2 pi, I am at 1, and from 3 pi over 2 to here, R is decreasing, but it's positive, so I am in a good shape. And we get this graph of the function. Now, of course, the first time I'm doing it, it seems very hard, but it's not very, very hard. The only hard part in this whole process is actually when R is negative. So whenever you get the graph of 1 minus 2 sine theta, whenever you know how R changed with theta, the first step you do, I mean, if you don't know how to graph, just look it up, but those are usually simple graphs. Ask yourself, when is R 0? And once you figure out when R is 0, draw the line that gives you the theta that gives R 0. And then you start reading verbatim. If R is positive, it's not hard. If R is positive, at theta go from 0 to pi over 6, you are in the same quadrant at theta, and R is just decreasing. When R is negative, that will become a little bit harder. Because now, when theta go from pi over 6 to pi over 2, R is negative, means the point that satisfies this equation are in the piece which is opposite to theta, not where theta is, opposite to theta. So that's the part that would give us hard time. And then we proceed after that. Okay? Now your calculator, I will take a few minutes. Your calculator, definitely sketch those. But without an understanding of what's really going on, the calculator really, you don't really know what it's doing. So I will just sketch that using our calculator. So, sorry. First you have, probably some of you know that, you have to go to mode. And you have to make sure it's in polar, absolutely. And then once you have that, it is in polar, you go back to the y and you enter the function. So 1 minus 2 sine of theta, you enter it. And then as usual, you go back to trace. And the calculator trace it. Okay. All right. But if you don't know what's happening mathematically, you really don't know. You know the shape, but you don't know really what's going on in there. So let me change the window so I can lift up the graph a little bit. So I'm going to change my x because, no, sorry, my y. Y minimum, I want it at least at 3, sorry, at -3. And max, it seems to me 1 will do. Okay, and I will trace it again, kind of. As you see, it doesn't really show me the whole picture. It tells me how it looks like, but not the whole picture. How do you put in polar again? I will show you in a minute, Mando. Just give me 1 second. So these are the values of theta. Now I can trace going through the value of theta. So are you guys seeing the calculator? So if I trace, so that's trace it. It trace, then all of a sudden, it's moving back. So the question is, that's where math comes into the picture. When is it starting to move? And when it is in this quadrant. So the calculator doesn't tell you exactly. It does give you an idea where it is, but it doesn't tell you why all of a sudden you're moving from here to here. And the reasoning is, that's what the calculator is doing, up to pi over 6. So I will trace it back from the beginning. This is at 0. And then as you move it, it hits the origin. This is the pi over 6. That's the value of theta equal pi over 6. After that, it's moving to this quadrant. Why it's moving to this quadrant? Because your r now is becoming negative. So if theta go from pi over 6 to pi over 2, r is negative. You are right there in this quadrant. That's what's happening on your calculator. Now at 3 pi over 2, the value is at pi over 2, so theta here, it tells you 1.5. 1.5 is actually almost pi over 2 because 3.14 divided by 2. So at pi over 2, we have a negative number. So at pi over 2, the graph is not here, the graph is down here. And then it keeps going. So I am at pi over 2. It keeps going because r from here to here remain negative. And then at some point, as you guys follow it, it hits the origin. That's happening at 5 pi over 6. So here your calculator gives you 2.6. The 2.6 is exactly 5 pi over 6. That's when it's hitting the origin again. After that, as you realize, now I'm going backward, which is not okay. After that, it's actually moving nicely. It moves. Now it hits pi. That's a 1. Now it's positive and it keeps increasing. The r is increasing. As theta increase, the r, which is how far we are from the origin, that's the r, how far we are is increasing. And then it keeps increasing. Okay, and that's explain what the calculator is doing. So by doing this picture here, I know exactly what's happening on my calculator, exactly what's really going on. I know why it's go like this at pi over 6 is switching there, even though theta is increasing, because the r, according to this formula, is negative. Okay, so for tomorrow, I would like you to basically do the problem. I will not assign a lot. Following the pattern I'm doing, you start with that and try to transfer the information to the actual graph. And then you can plot it on your calculator and see if everything is actually working between this piece, that piece, and your calculator. Okay. Now I will answer Amanda's question. You go to mode, and then if you while you put change from radian to degree, you go to mode, and then here there is function. It means y equal f of x. Parametric, this is where you put x and y as a function of a parameter t, and POL stands for polar. So you scroll down to polar and you enter polar. That's how you get everything in polar coordinates. Sketch most of the graph. Is it making sense, Mendo? Okay, so that's my calculator. I imagine yours is really the same. I don't know which calculator you have, but it should be fairly similar to what I am working with right now. Right? So for tomorrow, as I said, I would like you to work out those problems, even if they take a little bit of time, but they will be actually beneficial. Okay. Any other questions before? Yeah, I will have definitely office hours during the final exam week. I will post them on Blackboard. Yeah, there will be Zoom office hours, as you guys, of course. I will post them all on Blackboard. Everything is there. You guys have the review, and you have the answer to the review. You only have to work. That's about it. Just start studying. There is one thing I will do for the final, and I will have to do for also this quiz. I am in a situation where I have to give different version for the exam. It means your exam will have 3 versions, will be very similar, but some changes. And I will give version X, Y, and Z. And the way it will work is that right before the exam on Blackboard, I will be assigning to every student randomly one of them. It will be random. It means I'm not going to pick and choose. So before the exam, you go to Blackboard. Every student will have a letter attached to his name. And the student will have to take the exam that attached to the letter I gave him. If failure to do that will result in a 0 grade. All right, so for the final exam, and actually I will do that also for this coming quiz, so you practice, you will have a column on Blackboard, and on this column, each one of you will have a letter attached. Those letters will be chosen randomly. And I will have 3 versions of the exam. The questions are similar. Of course, they are similar. You guys will have the same thing. So if a student, I give him a geometric series with 2/3, the other group will be probably with 4/3. So there will be a lot of similarity between the question, but they will be different. And every student, before they start the exam, will have to go to Blackboard and choose the letter I gave them. So I gave you the letter X, you take exam X. I gave you the letter Y, you take exam Y. I gave you the letter Z, you will have to take the exam Z. Okay, you know that I didn't have to do that in class, but now because everything is online, we have to do those kind of things. I don't like it. It's 3 different exams, but there is nothing else I can do about it. Okay, so this quiz, I will follow the same pattern just so you guys get used to it. So I will give you letters for this coming quiz. You will have to abide by them. And for the exam, I will give you different letters, not the same, of course, different letters. They're going to be chosen randomly. The exams will be very similar. You have nothing to worry about. You just pick the letter that you're given and you go ahead with the exam. All right? Anything else? Any other questions? Okay, please fill out this evaluation because we need them, and I will see you tomorrow. Do your best with those problems. I will work over them tomorrow, and I still have one idea with polar coordinate, and we will be done with the course. All right, please join me in Zoom if you have any questions. Bye, guys.